Hi, this is Rosalina Sonata, and this video is the PowerPoint presentation for my course Project Completion for CS 201 Computer Programming 1. So here in my PowerPoint presentation, I have problem solving through flowchart, handling primitive data types, and the ifs. What is problem solving? Problem solving is defined as the systematic approach in searching solution or set of solution to specific problem. This can be in any form, such as listing possible solution or possible option to the most efficient scenario. We usually apply massive calculation to incorporate values to challenges and optimally solve smaller challenges until we complete our or solve the main problem. There. So we have that in everyday lives. Yeah, here. So what is flowchart? Flowchart shows diagrammatically steps required for a task subsystem. That's what we call the algorithm, and the order that they are to be performed. These steps together with the order are called an algorithm. Flowcharts are an effective way to communicate the algorithm that shows how a system or subsystem works. There are two types of flowchart. One is flowchart of algorithm, represent the sequence of operation and include program flowchart. The other one is represent the operation in system. On the other hand, we also use the other method to represent the algorithm, and it is what we call pseudocode, fake code. It is not written a specific syntax that is used by programming language and cannot be executed in a program. It's like you're listing all the scenarios and it's written in alphabet or English, but there's no ints or variables that we're using in programming. So later on, I'm going to show you the pseudocode and flowchart differences. Next. Gulo ng screen ko. So here, a sample of flowchart. This is the sample of flowchart. So flowchart is also a blueprint of a design you have made to solve the given problem. Of course, for example, we're going to create a design in the house. So architect will make a blueprint for it so they can execute the problem, or their problem is going to create a design for the house, right? So what architect will do the blueprint for the house so they can execute it properly and solve their problem. They create the designs there. It has various kinds of symbols and shapes that represent their specific actions. Like, for example, as you've seen on this side, there's different shapes, right? But I think it's only two shapes here. It's rectangle and square, but they have specific functions. And here is different shapes and functions of the flowchart, or the shapes that we're using when we create flowcharts. There are so many shapes that we can use for the flowcharts, but this is just the view, or just an example, not all of this, but here. Some of here we usually use, or basic flowchart shapes that we use when doing the blueprint. This one, there. So this is the most flowchart was this we usually use for the flow chart there. So as you see, there's a symbol name, and also it has a description for it. So it means that they have specific um, task or use specific usage for these symbols. Okay, like for this example, this is oval. Their symbol is terminal. It's either to start and to stop, or start and end task there. Terminals are used to represent start-stop of the flowchart there. You see these arrows, flow lines or arrows. Flow lines are used to connect symbols used in flowchart and indicate direction of the flow. Parallelogram, the input or output of the task or the program that you're going to create. Parallelogram are used to read input data and output or display information. Next is the, excuse me, rectangles. This is where the process going on. Like this is the execution, or for example, I'm going to buy food. You're processing the action there. Rectangles are generally used to represent process. For example, arithmetic operations or data movement. Like what I said earlier, it's action, movements, like that. So next, diamond. This is the decision. It's either yes or no, or true or false. Diamond shapes are generally used to check any conditions or take decision for which there are two answers. They are yes, true, or no. Yeah, false. There. Next is the connector. It's a small circle connection to the other flow of the chart. There. So it is used to connect or join flow lines. Annotation, like this. It has dash, as you see here, and half rectangle or square there. It is used to provide additional information about another flowchart symbol in the form of comments or remarks there. So, like for example, you're doing your flowchart, and then you want to comment or put some remarks on there. So there, you just need to use the unfinished square or rectangle and write it there. The other features here, there, we all have, most of these pictures have already in this side, but what do we have? What we don't have here is the triangle here. It's like the raw material storage, finished good storage. This one, the, what do you call this? Hexagon. Tama ba? Six, yes, hexagon. Initial setup and other preparation steps before start of the process flow. The other one is the alternate flow direction of information flow. Flow line dash, like what you see here on the other side, right? There's a flow line dash, and then the half of the square there. Next, how do I make a flow chart? In flow charting, we draw the symbols of flowchart or an algorithm indicate the specific information and process according to the symbols or shape of the flowchart to visualize the output that you want to attain and make your process flow understandable. So that's what you call flow charting. It's like what I've mentioned earlier is like listing all the possibilities that you want to visualize on your flow or your problem solving decision or scenario that you want to visualize, right? So, like, for example, I'm going to go outside, like what you see here. I'm going to go outside. So, this is the oval shape, right? That's the start and finish. And this is wait, this is the decision that I'm going to make. So I'm going to check if it's raining outside. Yeah, so if it's not, then there's no decision. And on the other side is yes, right? And that decision, like it's raining, I don't want to bring an umbrella. So no. So if I'm going to say yes, I need to do another few steps to go outside. Like, for example, I'm going to find an umbrella. Then yes, it's a decision. Then the execution or the movement that I take and the decision and the another decision, like I found the umbrella, right? I found the umbrella and then the other action that I'm going to take is bring the umbrella and then I'm going outside there. Yes. uh, there. So the next is flowchart control and structure and pseudocode. This is the flowchart example. This we have symbols, shapes, and their functions, right? There. On the other side, on my right side, facing the computer, this is what we call pseudocode. Like, if it's raining, then find the umbrella. If found the umbrella, then take the umbrella, right? It's a conditional statement. Then there's a yes or no or true or false possibilities. Yeah. If not found the umbrella, then check if it's raining. Else, don't bring the umbrella. And if end, then end of the story or end of the scenario. Second one is handling primitive data types. Handling data is similar as handling where we store and retrieve them. In computers, the data are stored and retrieved in the RAM, RAM. Programming make this possible through variables. It's like storage of variables, and within variables are values. Like, for example, I have a chest full of valuable things. And like I get the some of the random things on that chest, pressure chest. And then within that um, valuable things, there's a sentimental values, right? And that's what you call values. Like like I have here, it's like the storage of valuable things, the chest, and then there's a random valuable things on that chest, specific chest, and then within that variable things, like for example, my mobile phone or my passbook or what's that? Bank card, right? Bank card have money and money is inside the card. So it's value valuable. That's what I called That's what we call variables. And then within that, like for example, the money, that is the value of the card, right? So I hope I can execute it or explain it clearly. Next. Next, handling variables. In programming, when we declare the variables, it will retrieve the value of the variables in the program. Like, I have a card and there's a money inside that card. So the value of that valuables is inside there. It will retrieve the value of the variables in the program, but the value is still within the variable. What we take out of the variable to retrieve is just a copy of value. Like, I'm going back to the examples that I had earlier, is the chest box, right? So, like, doll is inside the chest box, and then I take it out. But that doll have sentimental values. The sentimental values is I already have in my mind, inside my mind. I already enjoyed it, experienced it, right? But, sorry. But I only put these toys or this doll inside that chest box because this reminds me of the moments that I had within this object, right? Therefore, it has a sentimental value. But the value I experience or the sentimental values that I experience on that doll is already engraved in me, right? Like this one. What we take out, the variable to retrieve, is just a copy of value. Same like handling variables. There. So variables, a value that can change depending on condition or information passed to the program. In program languages, we call it explicit, implicit, and anonymous variables. Data types. Data types are the restriction we place to variables that limit them to handle the specified type of data. In classification, we called it by value and by construct. We have implicit data and explicit data types. The explicit data types are often called strong type, or they can work independently. Explicit data types are taken depending on how they are stored or used, and it is called variant type. There. It depends on the condition, or it depends on what you want to input on your program. That's why it calls implicit data types. Next, this one is the primitive data types. Primitive data types are data of singularity by nature. They contain only values that they are supposed to contain. They do not have properties, other components, and internal functions. Primitive data types in C++ are classifiable in integers, floating points, and characters. This classification based on what specific values are allowed. Like what I have in my video, like you see the int, you see the bool, you see the float, yeah? That's what you call primitive data in programming. Integers, floating points, booleans are numerical values, whereas characters or textual values. Next, here, the integers. Integers are numbers without fractional components and don't support decimal points. Like, they are the whole numbers, right? So you see here the data type, regular integer, short integer, long integer. Then when you do the program, you use that on the library and type the regular in, something like that. So identifier, you see that in, short, long, here. In, short, long, the minimum value is negative you still see here, there's no decimal point. That's the minimum value, -2147 for, and then they're short, long, there. There's no decimal point here. In addition to these data types, we have signed and unsigned identifiers for integer data types. When we do not specify any of the two identifiers, C++ implicitly interprets them as if you have placed a signed identifier. Like what you see here, another example, a table, regular, integer, short, long data types. The identifier, as you see here, it's int, short, long, but this one, the identifier for this is unsigned int, unsigned short, unsigned long. And the minimum value here is 0, starts with 0, but on the other hand, it's negative minimum number to maximum number. There. Exceeding the set boundaries for the integer values result to what we call overflow. Causing overflows result to unexpected outcome, which typically result for the application to terminate. There. So, cannot be reached na. Ganun. Floating points next is our values that are numerical in nature. They also support decimal decision. Some are temperature, body mass index, and height. A floating point number is one where the position of the decimal points can float in any position necessarily rather than being fixed position within a number. Like they are not rounding up. It's like it shows the decimal point. Like what you see here, the data types, float and double, identifier, float and double, minimum, maximum. There. Next, Booleans. Don't know if it's right pronunciation, but there. Boolean values are classifiable to either true or false. Like it's usually used to conditional statement. Like um, like what I did on the exercise course project, right? So there's an age restriction. So if you are 17 and below, you cannot proceed the program. So it means it's false. And if it's your 18 and above, then it's true. Then you can proceed on the program. These are numerical in nature because C++ stores them as 0 or 0, but it shows 1. That's how it works. Internally, true value for Booleans are considered as non-zero positive integer. False value for Booleans are considered as 0. They are usually used as flags for specific scenario. So I have here the example. So here, this is the sample of Boolean. There. Initializing two Boolean variables. Boolean A is true. Boolean B is false. That's the condition. So there. If value of A is true, the value of B is false. There. That's the declaration of the program. Characters. Characters are the only primitive data type that is textual in nature. A display unit of information equivalent to one alphabetic letter or symbol. Regular characters can only present one character per variable. Strings can be represented as a series of characters and abbreviated as char or CHR or char. Char. Letters A to Z, digits 0 to 9, special characters, white spaces there. So for example, I'm going to um, make a program saying my name. So I'm going the character string there. Next, what about ifs? What is if statement and how does it work in C++? I already mentioned it earlier. So this is just the uh, presentation. If statement is a selection statement that allows more than one possible flow of control. It is used when we have an identified condition expression. It can be single or multiple expression. Like what I have in the program execution videos, right? There's a multiple expression. And in that conditional expression, like um, in a hotel reservation, there's an input like how many guests and how much is per head, like how many days they are going to stay in the hotel. So as you see in the video, there's an if, else, if, right? So um, in each guess, there's a specific price per person. Like one guess, it's only 1,000, but if it's two guess, it's only 1,800, right? So that's the multiple expression for the conditional statement. It allows you to control if a program enters a section of code or not based on whether a given condition is true or false. It can allow the program to select an action based on user's input. Like there's, I have 5 guests, then if the guess is 5, then the price for that, there's a specific price for 5 guests and how long they are going to stay in the hotel reservation. There. I input the 5 guests and then the output of the program will show the exact output that I want to show in that program. Next, what about ifs? There are kinds of conditional statement. If statement, if else statement, else if statement. There. If Solen is hungry, then she buys some food. Else, she buys some drinks because she's not hungry. Another example, like this is the sample program. Excuse me. Program to display whether a number is even or odd. See. So if is 0, print, then number is even. Else print if number is odd. What is the even numbers, right? So 0, 2, 4, 6, 8, 10, and so on. So if I'm going to input the odd numbers like they are not equal, like 1, 3, 5, 7, that means it's odd. And that's the conditional statement for the ifs, the if scenario for this program. So there, that's the end of my PowerPoint presentation for course project completion for computer programming. And I hope I execute or explain it properly. So thank you very much.